There we go. I think you can hear me now. Yeah. It's like, oh, my mic is muted. That would be a problem. Hmm. Is this section long? Um, no, I don't think I don't think it's super long, no. I don't think it's very long. It is the last section of chapter 7, though. Okay. We'll wait for another minute or two and then we'll get started. If it's just you and me today, it's just you and me today. So, just depends. Let's see here. Okay. If it's just us two, it's just us two. Just depends. Like I can't force people to come to class, so okay. Okay. I think we're fine. Oh, we got Anna. Anna's here too. All right. I think we'll go ahead and get started here. All right. Okay, let's get started with today. Welcome back to Wednesday, end of the week time today. So today, we are going to finish up the last section of chapter 7. I am going to skip I'm going to skip section 7.5. Okay. So I'm going to skip section 7.5. So I took off the homework for that section, and it'll just be like 7.4 and then 7.6 will be pretty much how the last section of chapter 7 is going to go. All right. So today, we're going to be talking about we're talking about some modeling here. So talking about modeling via a logarithmic perspective, exponential perspective. All right, that's essentially what we're doing here. But for us to actually understand that, we're going to need to answer some questions. So let's go ahead and do that right now. Okay. So exponential and logarithmic modeling, all right, is what we're doing here today. Okay, so let's talk about what each of these mean here. So first, let's talk about exponential functions. Okay, so what exactly are exponential functions? Well, exponential functions are going to kind of look like this. Let's bring out the math type. There it is. Okay, so exponential functions are going to look like this. It says f of x is equal to b to the x power. Okay, so this is how pretty much every exponential function, pardon me, is going to look like. Now, with every exponential function here, again, b here, again, what do we call b here? B here is the base, and x here is the exponent, okay? Now, there's a lot of different types of exponential functions, as you can probably already guess, such as a classic, say f of x equals 2 to the x power. Or again, you could have, for example, here you could have f of x is equal to 4 to the x minus 1 power, okay? Maybe plus 2. Okay, you can have that as an exponential function of some variety. It doesn't really matter. I'll just say it like this. Okay, so what we're going to do here first is we're going to go ahead and talk about, and we'll look at an example here, and we're going to go ahead and look at a graph about this by just mapping out some points. Okay, and we'll talk about some of the characteristics that we can certainly find and want to use. And then we'll also talk about logarithmic functions, and we'll also talk about, actually, I should also mention here, also quadratic. Yeah. Okay. All right. Okay, so let's go ahead and look at an example here. And we're going to go ahead and graph this one out and do an XY chart. So let's look at that right now. Yeah. Okay, so you hated logs in high school, I see. I'm sorry, you opened yourself up with that one, Fernando. Okay. Bro, you just asked for that one. Yep. There. That's about I'll throw shade at myself here. Oh man. To be fair. My total UR student is pounds. I just have way too many of them. I overcompensate. It's a problem. A big problem. Okay. All right. So here we got f of x is equal to 3 to the x minus 1 power. Let's make a little xy chart here. All right, so we're going to go ahead and, yep. Okay, so they pre-picked these values for us here in the book. So we're just going to go from -2 all the way up to 2, just one unit at a time. Okay, I'm going to start at 2 and actually work my way backwards. So how about 2 here? If we plugged in 2 into this function, what would we get here for this particular function? What would 3 to the 2 minus 1 be? What would that be equal to? 3. That's correct. All right. How about 1? Sorry for the noise outside. They're doing some yard work out there, so for the complex. So apologies about the noise. How about 1? What do we get there? What do we get here in this case? 3 to the 1 minus 1. Help me out here, guys. Well, so what's 3 to the 0 power, everybody? Hmm, 3 to the 0 is not 0. All right, I can wait all day, guys. You guys got to get into this. I know there's only 3 of you, but I gotta get you guys kind of going here. So, all right, the answer is 1. All right, let's try 0. It's still gonna ask me that question today. That's funny, man. There. Okay, how about 3 to the 0 minus 1? We have 3 to the minus 1 power. Let's remember one thing here about 3 to the minus 1 power. With 3 to the 0, anything to the 0 power is automatically equal to 1. Anything to the minus power here is going to be, let's see here, that's going to be, again, a to the minus n is equal to 1 over a to the n powers. So remember, you can change negative exponents to positive exponents. Okay. So what would 3 to the minus 1 power be? 3 to the minus 1 power, what is that? All right, 1/3. Very good. Okay, what about 3? How about 3 to the minus, oops. Actually, why did I put it there? Of all places. All right, how about 3 to the minus 1 minus 1? We get 3 to the minus 2. Remember, 3 to the minus 2? 1 over 3 squared, which is 1/9. So you get 1/9 here. And the last one here, I'll fill in. This will be 1/27. That'll be 3 to the 3rd on the bottom. Okay, let's take a look at a graph here, and let's see what we're looking at. So A couple of important things here is to remember these two factoids here when it comes to exponential functions of some variety. Okay, so we have, again, let's put in 1 comma 1 and 2 comma 3. 0 comma 1/3, so, it's kind of a here-ish. All right, negative 1 comma 1/9, so here and here. So again, it's a little bit difficult with -1, -2, but if you graph this, what does this look like here? This looks something akin to this. Okay, so here's an example of an exponential function. Okay, so this is a way we can make a table of writing things in exponential function. Sorry, bro. Gotta do my work. That's important, more important here. Teaching the maths. All right. Okay. So that's an exponential function, just like so. All right. Are there any questions about exponential functions? I got another class after this, my friend. Wish I could, but I can't. I got work. Sadly, even if I played Warzone, I think I'd be more of a hindrance than a help. All right, any questions about exponential functions before we move on? Okay. I mean, if you'd like to subscribe, you can. It's totally up to you, bro. I'm not gonna force the issue, though. I mean, it's very kind of you. But if you want to learn something, that's cool. I don't mind. Let's go ahead and do a logarithmic function now. That's be the next thing. So let's do that. Okay. So let's go ahead and take a look here at logarithmic functions. Okay. All right, so logarithmic functions here. Again, what do logarithmic functions look like? Well, logarithmic functions are going to look like this. Y is equal to log base b of x. So this is what a logarithmic function typically looks like. Now, what they're going to ask you here in this particular section is, of course, we'll look at an application with a logarithmic function, but we're also going to be talking about, say, how to graph a logarithmic function. So graphing a logarithmic function is just as important. So for us, in order to do that here, what we want to do is, although we don't have, say, log base, here's an example here of a log function. So a log function could look like this. F of x is equal to log base of 5 of x, okay? It could look something like this. Now the issue is that if you try putting this on a calculator, there's no such thing as log base 5. Unfortunately, we're kind of out of luck there. However, what we are given is we are given a quote-unquote translation function between a logarithm and an exponential function. So let's take a look at what that is here in this case. So here's our logarithmic function. So y is equal to log base b of x. And if we want to translate that to an exponential function, then what this actually goes to is this actually goes to be x is equal to b to the y power. So this is the log, this is the exponential. Now I'm going to go ahead and put a little note here in regards to this, because then you'll see exactly how this works out. So note here, look at the position of where the letters are to properly translate. Okay, so the position matters. When are my gaming streams? When most of my, if I were to do a gaming stream, it'd probably be on a Friday, Saturday, or Sunday. One of those 3 days, and I can do a gaming stream. Then most every other day is a educational stream teaching these math classes. That takes first priority over everything else. Now, mind you, I'm a very mediocre player, if not great. But, you know, if you just want to have fun and just sit and chill, that's cool. Hey, you got to be honest with yourself. Nobody's like the gaming god, you know? And that's the reason why I refuse to play competitive Overwatch ever again. There's too much toxicity in that game. Okay, let's take a look at an example of how we can, let's take a good look at an example here. Yeah, okay, so if I were to say that the problem that you have here is that, so the biggest issue that you have here is, yeah, when you have a really good popular game, right? When you have a really good popular game, then you start talking trash because other people are talking trash and stuff like that, and it's just too, you know, it's too, it becomes way too toxic after. Made it to Grandmaster with Junkrat, very nice. I love Junkrat, he's super fun. Like, I just play him in casual play, he's super fun. Uh, but yeah, like, it's a game. Sometimes I know we get mad when you play a game or something like that. I think we all have, right? I think we've all raged before, you know, but, you know, you got to sit back and think about it and say, okay, hey, it's just a game, you know. Quit being toxic. It's supposed to be a fun thing to do. When you make the game your job, then there's a problem. Then you've basically blurred the line between being super serious about something and then, you know, just enjoying yourself with, you know, a product that you really like. So that's when you start blurring that line, it's a good time to just kind of step back and be like, okay, let me take a break from this. I'll come back to it when I feel like I want to have fun with it, as opposed to be like super competitive 100% of the time. That's the way I feel about how games are. I don't need to deal with people who are like super toxic all the time. I just want to enjoy myself and I just want to have fun. That's about it. That's what gaming should be. You know, doesn't need to be like super serious all the time about everything all the time. So, yeah. Mind you, I'm not saying you don't want to win, but you're gonna try, but it doesn't mean like you could be a jerk about it either. All right, let's look at an example here. Yeah, let's use this. Okay, let's look at y is equal to log base 2 of x. And let's say we want to go ahead and make an xy table for log base 2 of x. All right, and we're going to use the same numbers as we did before. Okay. Oh, right. Oops. I do have something to actually say about that. So let's at least take those away for now. Okay, so the first thing that actually we're going to do here is we're actually going to translate this over to an exponential function. So let's go ahead and do that first. So we have y is equal to log base 2 of x. Now, the question is, what does y is equal to log base 2 of x translate to if we want to translate this to an exponential function? Okay. Oh, glad you can make it, Selena. So what does this translate to? If we use this translation here, what does this translate to? Can anybody tell me? Okay, that's correct. That's correct, Fernando. The answer is indeed x is equal to 2 to the y power. Now, this isn't actually this is definitely correct. Now, this is actually a very interesting thing that happens here. Now, if you take a look carefully, if this translates to x equals 2 to the y, normally what we do is we take a value for x, whatever value it is, we plop in a number in for x and we get a y back out. But if you look at this equation here, x is equal to 2 to the y, what this means is that if we plop in something in for y and get something back out for x, so now we're just basically, instead of going from left to right, from x to y, we're now going to go backwards here and we're going to go from y to x. And we're going to plug in some numbers here for y and x. Okay, so let's try some numbers out and I'll show you how this works here. So if I let's pick 0 for y. So again, we're just going right to left this time. If we pick 0 for y, what do we get here? So if I pick 0 for y, what's x? 1. Okay, good. That's right. Okay, let's pick another one. Let's pick 1. If we pick 1, what do we get? 2. Okay, good. How about 2? 4. So 2 squared is 4. How about minus 1? About minus 1. Let's 1/2. Very good. That's right. So again, remember that 2 to the minus 1 equals 1 over 2 to the first. Okay, and then we also have minus 2 here, which is a fourth. Okay, so as you can see here, it's not too hard to figure out what these points are, but these points are markedly different than that of the exponential. Again, everything is kind of in reverse. So if we take a look here at this, and let's the explanation for the logarithmic function. Yeah, there's a page for that. That is on page. Okay. Yeah, pages 473 and 474 for the explanation for logarithms. So if you like to reference those, you can. That's where I'm referencing that. No problem. I'm here to help. Okay, so we get 1 comma 0, 2 comma 1, 4 comma 2, 1/2 comma minus 1, and 1/4 comma minus 2. So what does this graph look like? The graph looks like this. Okay, so there you go. That is what a graph of a logarithmic function looks like. Okay. Any questions about logarithmic functions and what it looks like? Hopefully that isn't too bad. Okay. All right. Okay. Right and right and right. Okay. All right, next. Let's talk about the last type of function in here, and then we're going to look at some other examples, of course. Let's talk about quadratic functions, which if you've seen quadratic functions before, well, what I'm going to tell you should not be anything brand new. Okay, so what we're going to do here is what we want to do here is we want to find out several things about quadratic functions. Okay, so we want to first find out if the graph of a quadratic function opens up or down. All right, letter B, we want to find the vertex of said, and we'll describe what each one of these means. We want to find the vertex. Next, we want to find the x-intercepts, find the y-intercept, and actually graph it. So that's essentially what we want to do here for quadratic functions, is just kind of break it down into pieces and then find out each one of these individual parts. Okay, now let's go over the information here about how to determine whether or not we have parts for whether or not we have what information that we need to find here for particular quadratic functions. So I'm just going to go over the basics for each part, and then we'll go ahead and do an example. Okay, so the first part here talks about opening up or opening down. All right, so let's bring this over. All right, so find out if the graph of a quadratic function opens up or opens down. So if it opens up or down, basically what we wanted to look at is the basic idea of a quadratic function. What does a quadratic function look like? Well, it looks something like this. f of x is equal to, say, ax squared plus bx plus c. So again, a, b, and c can be whatever numbers that you want it to be. All right, again, you could have, say, 3x squared minus 2x plus 1 is a classic example, or again, x squared plus 5x plus 4. Wow, that looks terrible. Let's try that again. Okay, so here's another function that you could use, again, to in terms of what a quadratic function looks like. Now, if the graph opens up or down, that is actually dependent on a. So for the graph opening up, this basically says this. We want to look at just whatever number we have here, this leading coefficient. So if a here happens to be positive, so if a is positive, is bigger than 0, then it opens up. And what do I mean by opening up? The graph will look like this, like a letter U. So it'll look something akin to this. It's, again, it's a parabola of some type, but that's the generic shape of the graph. If it's less than 0, then it's just the opposite. Then it opens down. So there we go. It opens down just like so. Okay. Okay, so that is talking about how we can determine whether the graph opens up or opens down. Okay, let's talk about the vertex here. All right, so first and foremost here, let me go ahead and expand upon what the vertex means. Okay, and then we'll keep looking here. So vertex is the point where the graph